Let's start simple. What is an inverse function? Well, let's draw a coordinate system, and we'll make a drawing of a function. Let's call this y equals f of x. Now notice that for any x that we pick, any x value, there's exactly one y value. And that means that our function is invertible. Okay, so now imagine we want to find a rule that tells us for a given y value which x produced it. Well, the inverse function does exactly that. Y equals f inverse of x. Let's look at an example. If f of 2 equals 5, then that implies f inverse of 5 equals 2. The inputs and the outputs get swapped. Now to represent that graphically, we draw the y equals x line. And the inverse function gets flipped about the y equals x line. Because again, the x and the y values are swapped. The outputs of f become the inputs of f inverse. F inverse undoes f. And we can even see that the slopes kind of swap. Look at this slope here. It's very steep. And in the same area, the same region, this slope is very gentle. And likewise here, this slope is very steep in this region. And this slope is very gentle. So the slopes are reciprocals. So dy dx, the derivative of y with respect to x, equals f prime of x, implies the derivative of x with respect to y is the reciprocal 1 over f prime of x, because the slopes are swapped. Alright, follow along for more. Alright, quick recap from last time. Let's graph two functions. Let's say this is y equals f of x equals x cubed. It's just a part of that function. And let's say this is y equals f inverse of x, which is the cube root of x. If we pick a point 1, 1, and we look at both of their slopes, we'll see this slope here is 3. And this slope here is 1 over 3. They're reciprocals. And that brought us to the idea that dy dx equals f prime of x implies dx dy equals 1 over f prime of x. So let's derive the general formula for the inverse derivative. Let's start with a function y equals f of x. Pick a point xy, and the slope there is dy dx equals f prime of x. So the inverse asks the reverse question. For a small change in y, how does x change? To answer, we temporarily treat x as a function of y while using the same curve. And we differentiate both sides with respect to y. So d dy of y equals d dy f of x. Now we're using implicit differentiation. The left side is 1, and the right side is f prime of x dy dx. I'm sorry, dx dy. Dx dy. Okay, so we solve for dx dy, and dx dy equals 1 over f prime of x, just like we found earlier. Okay, so now finally, to express this as a function of the usual input of x, of f inverse. Remember, the x we plug in is the old y of f. So we replace x in f prime of x with f inverse of x. So it looks like this. F inverse prime of x equals 1 over f prime f inverse of x. Alright, hope that was helpful. Follow for more. Last time we found that if two functions undo each other, so they're inverses, then their slopes are reciprocals at matching points. And that rule, or formula, was this. F inverse prime of x equals 1 over, on the inside we just take f inverse of x, and then we take f prime of that. So let's look at a couple examples. Let's say f of x equals x cubed plus 1. To find its inverse, you just swap the x and y. We say x equals y cubed plus 1. And then you solve for y, and you get y equals the cube root of x minus 1. So, in this case, f inverse of x equals the cube root of x minus 1. Now how about f prime? F prime of x, just taking the derivative of that, that's 3x squared. So let's look at our formula. We'll just plug stuff in. F inverse prime of x equals 1 over, let's do the inside, that's cube root of x minus 1, and then we do the outside. 3, put the squared there. Just plugging things in, matching them up. Let's do one more example. Let's say f of x equals e to the x. Well, then we should probably know by now, and if not, we should learn that the inverse of that is simply ln x. And the derivative of that is also e to the x. That's a good one to memorize. So now we just follow the same rule. F inverse prime of x equals 1 over, let's do the inside, that's ln x, and then we do the outside, we take e to that power, and the final answer is 1 over x, because e to the ln x is just x. Okay, hope this series is helping you. Please give a like, a follow, a save, a share, all those good things. Press all the buttons. I really appreciate it. And I'll see you for the next one. Let's do one more example of inverse derivatives. This one will be trig. So remember our formula. F inverse prime of x equals 1 over f inverse of x. And then we take f prime of that. Now let's say our function is sine of x. Then f inverse is just arcsine of x. And the derivative of sine of x is cosine of x. So we plug that into our formula. We say arcsine of x prime, that's just this piece here, equals 1 over, plugging stuff in, arcsine of x, and we take cosine of that. That's pretty much a successful use of the formula, but now we can do some trig. So remember that when you see arcsine of x, it means the angle whose sine is x. Let's call that angle y. So sine of y equals x. Now we can model that with a right triangle. Let's draw one now. Draw a triangle here. Let's say the angle is y. It's a right triangle. We'll say the opposite side is x. hypotenuse is 1. So since sine is opposite over hypotenuse, this makes sense. Now we can use the Pythagorean theorem to find the adjacent side. So adjacent equals square root 1 minus x squared. So cosine of that same angle is cosine y equals adjacent over hypotenuse. And that equals square root of 1 minus x squared. And because y equals arc sine of x, we can say cosine of arc sine of x equals the square root 1 minus x squared. So the final answer, arc sine of x prime equals 1 divided by square root 1 minus x squared. There we go. Really, the easy part was using the formula, and then we just have to remember some trig identities to do that bottom part down there. Okay, if you like this, give me a like, give me a follow, comment, share, save, do all that stuff. I really appreciate it. It helps a lot. I'll see you for the next video. Let's do a quick refresher on implicit differentiation. Suppose you have the equation x squared plus y squared equals 1. You might recognize that as the equation of a circle. And let's say we want to find dy dx, which is the same as y prime, which is the slope. So say we want to find the slope of a point on this circle. Well, there's a bit of a problem here, and that's that y isn't solved for x. You notice it's y squared, so that's a bit tricky to solve it. So what we can do is treat y as a function of x, like that. And then we can use implicit differentiation. So we differentiate both sides with respect to x. So that's the left side, and then we take dx of the right side. And now the first term is easy because we're differentiating with respect to x, and the variable is x. So we just do the normal derivative, and we get 2x. But the second term is a bit trickier. So remember, we're going to treat it as y of x. And here it's squared, see? So we can use the chain rule. First we differentiate the outside. So we bring that exponent down, and we get 2y. We could even say 2 times y of x. But then we have to differentiate the inside, and that's y prime of x. So that's just the normal chain rule. Differentiate the outside, multiply that by the derivative of the inside. All right. So that means we have 2x plus 2y y prime. And then on the right-hand side, the constant goes away. And now we just solve for y prime. So we say 2y y prime equals negative 2x, and then y prime equals negative x over y. So now we can find the slope of any point on that circle just by plugging in the x and y coordinates. All right, I hope that helps. I'll see you for the next one. What is the point of a second implicit derivative? Let me tell you with an example. Say you have a circle, x squared plus y squared equals 1. And then let's say you find the first implicit derivative of that. So y prime. That's actually negative x over y. And you can look at my last video to see how to do that. But anyway, let me show you what that means. That's the first implicit derivative. Let's draw this circle. And let's say you pick some point on that circle. Let's say right here. And you look at that x value and you look at that y value. You plug those into this formula, the x and y values, and you'll get out the y prime. And the y prime, as you know, is the slope of that point. Okay, so what is the second implicit derivative? Well, let me just tell you that y double prime of this circle is negative 1 over y cubed. In the next video, I'm going to show you how to find that. But for now, just take it for granted. You can trust me. So what does that mean? Well, let's take a look at this. If we plug in a positive y value, let's say we take a positive y. Well, where are the positive y values? They're all up here on the top half of that circle, because the bottom half is below the x-axis. If we put in a positive y, what do we get out? We get out a negative y double prime, because it'll be negative 1 over a positive number. So what does that mean? Well, the second implicit derivative is the curvature. So it's going to curve down. And you can see that. It curves downward. Okay, so what if we take in a negative y here? Well, all the negative y values, as we said, are down here on the lower half of the circle. If you put in a negative y, you're going to get a positive y prime, y double prime, because negative over negative is positive. And it's going to curve upward. So the second implicit derivative is the curvature. All right, so in the next video, I'm going to show you how to find the second implicit derivative. Thanks for watching. How do you find the second implicit derivative? Let's do it. First, we have to find the first implicit derivative. So we take d dx of both sides of the equation, and that gives us 2x plus 2y times dy dx. We have to multiply by dy dx because we're using the chain rule, because we're taking the derivative with respect to x. Okay, the derivative of a constant is 0. Let's isolate dy dx, so we get 2y dy dx equals negative 2x, and then we can divide by 2y, and we'll get dy dx equals negative x over y. And that is y prime, the first implicit derivative. Let's find the second. So again, we take d dx of both sides of the equation. Dy dx equals d dx of negative x over y. Okay, on the left-hand side, we get d squared y over dx squared. That's just the notation for the second derivative of a y with respect to x. On the right-hand side, we have this negative. Let's pull that out front. And then we'll use the quotient rule. So that's y times the derivative of x minus x times the derivative of y all over the denominator squared. Okay. And let's continue. We have y minus x times something here. Now what's that something? Well, we found that dy dx equals negative x over y. So let's plug that in and continue simplifying. So we have y plus x squared over y. So now we can find a common denominator in the numerator, and that'll be y. So we'll get y squared plus x squared over y. And now notice that we are given that x squared plus y squared equals 25. So we can use that. We could say 25 over y squared. And now finally we have negative 25 over y cubed equals d squared y over dx squared, which is the second implicit derivative, y double prime. All right, hope that helps. Thanks for watching. Can you find the second implicit derivative of this thing? Let's give it a shot. We take d dx of both sides of the equation. d dx of y. So we're taking the derivative with respect to x. So the derivative of x is 1. The derivative of e to the y is just e to the y times y prime. We have to use the chain rule because the variable is y, and we're taking the derivative with respect to x. Right-hand side is just y prime. Let's get all the y primes on one side. So that'll be e to the y prime minus y prime equals -1. Factor out the y prime. That'll be e to the y minus 1 equals -1. And then we can divide. We get y prime equals -1 over e to the y minus 1. Factor out the -1. That's just 1 over 1 minus e to the y. So that's y prime. Let's go for y double prime. So we have to take the derivative again, d dx of both sides of the equation, d dx. Let's bring this up top, make it simpler to work with. So that'll be 1 minus e to the y to the -1 power. And let's see, we get y double prime equals, we have to use the chain rule. So that'll be, bring down the -1, 1 minus e to the y to the -2, that's just the power rule, times the derivative of the inside. Derivative of 1 is 0. Derivative of -e to the y is -e to the y times y prime. We did that earlier, something very similar. And what does this equal? This equals, let's see, that'll be e to the y prime over 1 minus e to the y squared. Okay. And now we can use this here. We can plug this in. So let's continue this, and let's say that equals, we need some room here. So this equals e to the y, and then y prime is this. So we can plug that in. 1 over 1 minus e to the y. All over 1 minus e to the y squared. And that equals, final answer is e to the y over 1 minus e to the y cubed. All right. Hope that helps. Thanks for watching. Let's find the inverse derivative of a function followed by the second implicit derivative of an equation. So we'll start with the function f of x equals x squared plus 1, where x is greater than or equal to 0. Let's find the inverse. So we'll set y equals x squared plus 1 and solve for x. So x squared equals y minus 1, which implies that x equals the square root of y minus 1. So that tells us that f inverse of x equals the square root of x minus 1. Now let's find the derivative. So f prime of x equals, that's just 2x. Okay, so recall the formula for the inverse derivative. So f inverse prime of x equals 1 over f prime of f inverse of x. There we go. Now we just plug stuff in. So f inverse prime of x equals 1 over, what's f prime? 2x. So 2, and then what's f inverse? Square root of x minus 1. So that is the inverse derivative of that function. Okay, so now let's look at a similar expression, x equals y squared plus 1, and let's find the second implicit derivative of that. So we'll take d dx of both sides of the equation, d dx of y squared plus 1. Left-hand side is just 1. Right-hand side is 2y times y prime. We have to use the chain rule since we're differentiating with respect to x, and the variable is y. Okay, let's solve for y prime. So y prime equals 1 over 2y, which also equals 2y to the -1 power. There we go. Let's find y double prime. So y double prime, we take d dx of both sides of the equation again. d dx of y prime equals d dx of 2y to the -1 power. Okay. Now what does that equal? We just use the power rule, bring down the -1, 2y to the -2, and chain rule again, so that's y prime. Okay, let's just rearrange that. So that's -1 over 2y squared times y prime. And what is y prime? Well, y prime is right there. So that equals -1 over 4y cubed. Okay, so we just found the inverse derivative of a function and the second implicit derivative of an expression. Hope that helps. Thanks for watching. Here's everything you need to know about inverse and implicit differentiation. Suppose you have f of x equals x squared, where x is greater than or equal to 0. Well, f inverse of x is square root of x. So let's graph these really quick. Here we go. I guess we can just keep these positive, huh? Okay, so square root of x is going to look like this, and x squared is like that. The reflections about the y equals x line. Okay, so now let's pick a point. Let's say x equals 4. So 1, 2, 3, 4. This will be at 4, 2. 1, 2 on the square root of x. Well, where would that be on x squared? So that'll be at 2, 4. So 1, 2, 1, 2, 3, 4. Right there. So those points are inverses. And the interesting part is that their slopes are reciprocals. So the slope here is like that. Well, the slope here is just 1 over that slope. They are reciprocals. Okay, so that's what we need to know about the inverse derivative. And here's the formula real quick. F inverse prime of x equals 1 over f prime of f inverse of x. Okay, so how about implicit differentiation? Let's say we have a circle x squared plus y squared equals 1. Well, if you take the inverse derivative of that, if you take the implicit derivative of that, you get y prime equals negative x over y. And what does that mean? Well, if we draw the circle, if we pick a point anywhere on the circle, say right here, we can plug in those x and y coordinates, and we'll get the slope at that point. All right, well, how about the second implicit derivative? Well, that's going to equal negative 1 over y cubed. And what does that tell us? Well, if we pick a y value, any y value, it's going to tell us what the curvature is. So if we pick a positive y value, we're going to see that the curvature is down. It's negative. It curves down. If we pick a negative y value, just look, you plug in a negative here. Negative over negative is positive. That means it curves upward. All right, I hope you enjoyed this series. I hope it was helpful. Go back and check out the other videos if you haven't. You'll see plenty of examples and other good stuff. And thanks for watching.